Special relativity is the reconciliation of two seemingly contradictory experimental facts by the counterintuitive relaxation of a basic assumption about the nature of space and time. The assumption is that there is a universal notion of space and time that everyone can agree on. This means if one person says that two events happened at the same time, everyone will agree. If another person says that their flight from London to Paris took an hour and 15 minutes, then everyone will also agree. And finally, if a third person says that the length of a stick is a meter, then everyone else who measures the length of the stick will also measure a meter. Makes sense, right? But it's wrong. So what are these experimental facts? The first can be attributed to Galileo. Imagine yourself in the bottom cabin of a fast-moving ship. It's a mild day, so there's no turbulence rocking the boat from side to side. Galileo realised that without the visual aid of the land ahead, no experiment can be done in the cabin to prove the ship's fast motion. A ball thrown up in the air falls to the ground just as it would if the ship was docked at bay. Crucially, a ball thrown in the direction of the boat's motion and in the opposite direction with the same force both have the same speed. Newton also realised many years later that his own laws of mechanics were completely independent of the absolute velocity of an object. The resultant force on an object only cared about how much its velocity changed with time, not what the actual velocity was. Every observer that is not accelerating can rightfully claim to be at rest. In fact, you can imagine having any constant speed that you want, and absolutely no result of any experiment you perform within the cabin will change. There is no absolute sense in how fast you are going, because you can just arbitrarily make it up, and no experiment will ever prove you wrong. What can be said, however, is how fast you're going with respect to another object. This can't just be arbitrarily made up, and so it does make sense to talk about relative velocities. Another way of saying this is that there's no preferred frame of reference. Your reference frame can be thought of as a coordinate system that it's at rest relative to you. If another object is moving with respect to this coordinate system, then it's not in your reference frame, but is in a different one. That object can also play the same game and define a coordinate system that is at rest relative to it, defining its reference frame. If all possible reference frames are denoted by a different coloured coordinate system, then this experimental fact states that there is no preferred colour. I want to strongly emphasise a point here. You are never moving relative to yourself. It may seem obvious, but it's a great source of confusion. Because you're never moving relative to yourself, you never experience special relativistic effects happening to you. It therefore doesn't make any sense to say that special relativity becomes apparent when you move close to the speed of light, because you always have a relative velocity of 0 with respect to yourself. Special relativistic effects only become apparent in objects that move close to the speed of light relative to you. So what's the second experimental fact? Imagine a tennis ball being thrown at 10 miles per hour out of a car window going at 20 miles per hour relative to the pavement. An observer on the pavement will say that the tennis ball has a relative velocity of 30 miles per hour. 20 miles per hour from the car, plus 10 miles per hour from the tennis ball being thrown. The person in the car, who can claim not to be moving from the first experimental fact, we'll say that the tennis ball has a relative velocity of 10 miles per hour, not 30. The point is this: the two observers who are moving at a relative velocity with respect to each other disagree about the relative velocity of the tennis ball. The amount of disagreement is exactly equal to the relative velocity between them. This originates from the fact that the motion of the tennis ball is created in the reference frame of the car, and so it carries the motion of the car with it. Unlike the tennis ball, sound waves behave slightly differently. Sound waves don't carry the motion of the reference frame in which they're created, but instead belong to the reference frame of the medium that it propagates through, air. If the driver creates a sound, they will measure it travelling faster when propagating behind them and slower when propagating in front of them. The observer on the pavement, who is still with respect to the air, measures the speed of the sound wave as the speed of sound. Clearly, both observers still disagree on the sound's relative velocity. The same is, however, not true of light. If a laser was used instead, both observers actually end up agreeing upon the relative velocity of the light beam. This is an extremely weird and strange fact about light and our universe. This fact was first shown by Michelson and Morley in 1887 by measuring the speed of light in the direction of the Earth's motion around the Sun and 90 degrees to this motion. Imagine that light is created from a particular reference frame, just like the tennis ball's motion is created in the reference frame of the car. In fact, light was actually expected to behave a bit like sound waves at the time, and was heavily suspected to travel through a medium called the ether. As the Earth moved around the Sun and through the ether, it would move relative to the ether at 70,000 miles per hour quicker in the direction of the Earth's motion around the Sun than at right angles to this. Therefore, we should at least expect the measurement of the speed of light to be different in both cases. They were, however, found to both be the same. So what's the conclusion? There is no ether. The motion of light does not originate from a particular reference frame. The motion of light originates from the reference frame of the person observing it. Imagine a rocket ship moving very fast away from you. It then fires a light beam towards you. In the case of the tennis ball, its motion was created in the reference frame of the rocket ship, and so appears to come towards you more slowly. However, with light, you see the light beam coming towards you at the speed of light, as if the beam was created in your reference frame. Remembering the first experimental fact, that from the perspective of the rocket ship, it can claim to be at rest as it travels with a constant velocity, from its perspective, the light beam, which appears to have been created in its frame, also travels at the speed of light. The same is true for every possible observer going at every possible constant velocity. Everybody always agrees that the relative velocity of light is exactly the speed of light. These two experimental facts seem to greatly conflict with each other. Next time, we'll see how, by abandoning the assumption of a universal notion of space and time, the fact of there being no preferred reference frame, and the speed of light being the same in all possible frames of reference, can be reconciled.